is corrosion control. There are various methods we adopt to control the corrosion. So, in that particular, the corrosion controlling method, they are broadly classified under four category. The first type of corrosion controlling method, what we call it as a coating. It may be a metal coating, maybe organic coating, maybe inorganic coating. Okay, metal coating or the coating of a suitable metal over the surface of base metal. Or we may carry a cathodic protection or anodic protection. That is, we convert the entire surface into cathode, and that method what we called it as a cathodic protection. If you convert the entire surface into anode, called it as an anodic control. Okay, and the fourth category of controlling method is a use of corrosion inhibitors. We may use certain inhibitors to the corrosion medium, or while manufacturing, while changing the surface properties, we will usually subject the metal surface into a metal finishing process. During that time, we may introduce some inhibitors to the metal. As a result, it's possible to reduce the rate of corrosion. Okay, we may carry a coating method, corrosion, use of corrosion inhibitor, cathodic protections, and anodic protection. Out of this, I'll discuss a few methods to control the corrosion. So, in that, the one method comes under inorganic coating is a anodizing. So, under a coating process, we may carry a inorganic coating, metal coating, or organic coating. The organic coating is nothing but the use of paint, an organic material, oil. So, whereas in metal coating, we may use a metal to protect the base metal or the inner surface of the metal. Okay. And third, inorganic coating. Under inorganic coating, we change the surface properties of metal by converting into their compounds. And that method, what we called it as a, generally we called it as a inorganic coating. We just change the surface metal into a suitable compound. As a result, it helps to reduce the rate of corrosion, because the formed compound itself acts as a barrier between the underlying metal surface and the corrosion environment. And that method, what we called it as inorganic coating. Under inorganic coating, we come across two categories. The one is anodizing. The second method is phosphating. Phosphating method is nothing but we convert a surface layer into a metal phosphate by using suitable phosphating salt. Okay. In this case, anodizing, it is included in your syllabus. So that's why I'll take in detail. Okay. Anodizing is the conversion of a surface into metal oxide. So a surface, a metal present, and this metal we converted in the metal oxide form. And that metal oxide, the surface metal is changed into metal oxide and get deposited over the surface of metal. Okay. And a very thin, stable products are formed. Very thin and stable products are formed, and that itself acts as a barrier between the underlying metal surface and the corrosion environment. Okay. So, the anodizing can be defined as the process of developing an oxide film on the surface of the metal by chemical or electrochemical reaction. Just by dipping process possible, but in the case of aluminum, it is not possible. We usually adopt a electrochemical method. Okay. For any electrochemical process or it is like a conversion of surface metal into a suitable compound. For all electrochemical process, we need electrical energy. That means to carry that process, we have to supply a particular, we have to apply a particular volt of potential. Like if it is more, almost all metals get dissolved. If it is less, then less dissolution take place, and it is difficult to get a desired thickness deposition. So that's why we have to introduce a suitable potential, and we have to take a suitable electroplating bath solution. We use an anode and cathode. Okay. Then if we apply a potential of certain, we can develop some current potential. And what type of reaction that takes place? In the case of anodizing of aluminium, here article to be anodized always degreased first using organic solvent. Okay, it otherwise interfere during the reaction. So that's why we have to remove almost all extraneous matter that were deposited over the surface of anode. Okay, so first it should be degreased. Then after degreasing, even if any thick deposition is observed, we may introduce acid treatment. That is what we called it as a pickling. And then it is a polished, washed with water and dried. And that component is taken and that article itself act as aluminium. Okay. If you observe the electroplating bath, here the aluminium act as a aluminium article to be anodized. Here electrical energy is supplied, so anode is a positive charge. Okay, aluminium article to be anodized. The cathode is made up of a copper or a steel. The copper or steel is taken as cathode. Okay, aluminium anode, cathode is copper or steel. Aluminium act as anode. And in the electroplating bath, we have to take a component which can able to form oxygen and they combine with aluminium forming an oxidized product or help for the oxidation reaction. For that purpose, we'll take 10% chromic acid or 10% sulfuric acid. Even sometime mixture may be used. Oxalic acid like mixture may be used. Here, we'll take either 10% chromic acid, help for the oxidation process, or 10% sulfuric acid. Okay. Then, the temperature of this bath maintained is around 30 to 40 degrees Celsius and you have to apply a potential of 40 volt. As a result, a current density 10 to 20 ampere, milliampere per centimeter square is developed. Milliampere per centimeter square is developed. Then what are the possible electrode reaction? Always the anode reaction is an oxidation reaction. What is the component present in the anode? Anode component is aluminium. And here the electrolyte is a chromic acid or a sulfuric acid. It's only 10%. So usually aluminium interact with the water components and get oxidized to aluminium oxide. Al2O3 is formed. Okay, it get oxidized to aluminium oxide along with the liberation of 6 moles of electron. It liberates 6 moles of electron. This is a possible reaction when you use aluminium as an anode. In the electroplating bath contains chromic acid and sulfuric acid. Aluminium interact with water and get oxidized. Anode reaction. So that is an oxidation reaction. Liberation of electron take place. And what is a possible cathode reaction? And you know, these liberated electron usually migrate towards cathode. And here the already acid is present, that is H plus ions, and these H plus ion takes electron and liberates hydrogen. Okay, it's an easy way of reaction, cathode reaction. Say 6 moles of H plus combined with the 6 moles of electron and liberates 3 moles of water. Okay, so this is a possible cathode reaction. What is a net reaction? The net reaction is the sum of the two reactions. Here, this get cancelled. 6 moles get cancelled. It shows like just an interaction between aluminium, okay, in the presence of water, okay, H2O, 3 moles. See, giving rise to aluminium oxide. It is just like a natural oxidation process. If you carry this under natural condition or common conditions, so it takes longer time. So that's why it is subjected to electrolytic or electrochemical reaction. So oxidation takes place as a result a very thick deposition that take place over the surface of cathode. Okay. That take place. That anode is dissolved, and again you know that aluminium ion is present. It get oxidized and it form the compound. Usually anode get the product is here, the deposited and over anode and get deposited. Here, it's not possible to deposit. The liberation of hydrogen take place, and we use copper and steel as a cathode. Okay, so in this way we can able to carry a anodizing process. Okay, and if you carry anodizing process, usually aluminium get oxidized to aluminium oxide and get deposited over the metal, because it is an anode, so it get deposited over the metal. The anodized coating are very thicker than the natural oxide film and possess improved corrosion resistance, as well as it is improved mechanical injuries, because it is a thick deposition compared to the natural oxide film. And further, if you want to increase the corrosion resistance property, it can be subjected to sealing process. If you want to dye that product, you can introduce a suitable dye at a temperature 50 to 60 degrees Celsius. That is why the article then dyed by immersing in a solution of the dye stuff at 50 to 60 degrees Celsius. So the corrosion resistance of the film can be increased by sealing process, which involves heating in a boiling water or a steam. Finally, article should be well washed with a nickel acetate. Okay, so this way we can able to carry anodizing process. Okay, so here in anodizing process, the article to be anodized is taken as anode, then steel or copper is taken as cathode, then electrolytic process is carried out with the temperature 30 to 40 degrees Celsius, potential 40 volt, current density 10 to 20 milliampere per centimeter square. Then electrolyte used is a 10% sulfuric acid or 10% chromic acid. The possible electrode reaction is aluminium in the presence of water gives aluminium oxide with the formation of 6 moles of H plus and 6 moles of electrons. That 6 moles of electron and 6 moles of H plus combined to form as a result liberates hydrogen on the surface of cathode. So the net reaction is the deposition of aluminium with the liberation of hydrogen. Okay, if you want, I can represent once again here. The aluminium combined with the water H2O giving rise to aluminium oxide Al2O3 with the formation of 6 moles of H plus 6 moles of electron. To balance this one, 2 moles of aluminium and 3 moles of water is needed. As soon as H plus is formed, it undergo reduction and liberates hydrogen. Okay, so the net reaction is 2 moles of aluminium plus 3 moles of water giving rise to Al2O3, the corrosion product, or in other words, it is just a product, and that product get deposited over the surface of the metal. Okay, and if you want a colored metal, then you have to introduce a dye at a temperature 50 to 60 degrees Celsius. If you want to improve the corrosion resistance, then you have to carry a sealing process which involves heating in a boiling water or a steam. Finally, the article is treated with a nickel acetate followed by boiling. Next, I'll take the next method, that is a metal coating. Under metal coating, there are two types of metal coating possible. The one is anodic coating, the other one is cathodic coating. Okay, anodic coating and cathodic coating under metal coating. Okay, anodic coating is a more active metal is coated over the base metal. So, if you want to protect a metal like iron, it is coated with a more active metal like zinc. Okay, a zinc coating is carried out. That is, this zinc is anode with respect to iron. So that's why the coating called it as anodic coating. In the case of cathodic coating, so more stable metal is coated. Like if you want to protect iron, it is coated, or even in case of copper, it is coated with a tin. Okay, so copper, in order to protect a copper, it is coated with a tin metal. and this tin acts as cathode with respect to copper. So that protection, what we called it as a cathodic protection. Okay. Depending upon the coating method, we'll name it as an anodic protection or anodic coating or cathodic coating. Okay. So in case of anodic coating, more active metal is coated over the base metal. Here, in the case of cathodic coating, the less active metal is coated over the base metal. Among the two kinds of coating, the anode coating is a preferred one. This one is a preferred compared to this. But in some cases, it is not possible to carry anodic. In such a situation, cathodic coating is usually adopted. So, anodic coating, why it is preferred? Because even a small rupture in the coating is observed. So, the entire metal is coated with another metal. So, in some cases, there may be a rupture in the coating if it is observed. Okay. There may be a rupture in the coating is observed. So, even the coating gets ruptured, the inner metal is not affected. See here, the metal is coated with the another metal like a zinc metal. If you observe any uneven deposition or a small porous is developed due to atmospheric interaction, even though the inner metal does not get corroded or it's not corroded. The reason, the outer area metal itself acts as an anode. First, after complete this one corroding, the environmental component attacks the inner metal. So that as soon as the anode metal is present over the surface of base metal, the metal is protected. Okay. So that's why the anodic coating is better compared to cathodic. In case of cathodic coating, this metal is a cathode. This metal is anode, whereas the coated metal acts as a cathode. Okay, a small rupture in the surface of the cathode, resulting in the formation of small anode and a large cathode, resulting in accelerated corrosion. A fast corrosion takes place. So that's why among the two types, the anodic coating is a preferred one, but even we will carry a cathodic coating in certain situation. In that case, it's not possible to carry the anodic coating. Okay. So these are what we called it as a metal coating technique. So we may introduce anode metal over the surface of base metal or a cathode metal over the surface of base metal. Depending upon that, we will consider as anodic coating or cathodic coating. So metal coating, generally metal coating is nothing but applying a suitable metal over the surface of base metal. Okay. By the process may be carried out by just a hot dipping process. In this method, usually producing a coating of low melting. In case of anodic coating, particularly under metal coating, I'll consider anodic coating. In case of anodic metal coating, usually it is produced by coating a low melting metal such as aluminium, zinc, tin, etc. on iron or steel. In preference, in particularly zinc coating is carried out, which have relatively high melting points. Okay, this point usually high iron. So the example for metal coating is galvanization and tinning. The galvanization is an example for anodic coating and tinning is a best example for cathodic coating. Under metal coating is a coating of suitable metal over the surface of base metal. It considered as a cathodic process. Considered as a metal coating. Okay. Galvanization. Then what is this galvanization? The galvanization is a anodic coating. It is a anodic coating a base metal with a more active metal. It is a process of coating zinc. Particularly galvanization is coating of zinc metal on iron or steel by hot dipping process. Just by hot dipping process will carry this process. Okay. So this zinc is a low melting point compared to iron. So that is around 420 degrees Celsius. It will melt. As a result, by hot dipping, it is possible to carry a galvanization process. So galvanization is a process of coating of zinc metal or iron, on an iron or a steel by hot dipping process. Okay. For example, for the this one cathodic coating, a good example is a tinning. The other, that is a coating of base metal with a thin metal, but again by hot dipping process. But in your syllabus, it is restricted only a galvanization. It is a process of coating of zinc metal on iron or steel by hot dipping process. Then how we carry this process? You may observe the pictorial representation of the process. See, I'll use some iron sheet. Okay. So usually this process is carried out at the end of the or at the final stage of the manufacturing process. Say here, iron sheet is taken usually in any metal coating process. So in any, this process is galvanization. In any metal coating process, before carrying a coating process, it should be properly treated, or the process what we call it as a pre-treatment. Okay, if you carry a pre-treatment, so that any extraneous matter, if it is present over the surface of the metal, so it gets clean. Otherwise, so corrosion of metal, the attack by environmental constant on the metal surface may possible. To avoid that one, it should be properly treated. So for that purpose, in any process, the galvanization or tinning, first the sheet is treated or it is dipped in an organic solvent. Okay, the iron sheet usually dipped in an organic solvent. So that when you dip in an organic solvent, any grease or oil particles are removed. Okay. When you dipped it in, the sheets in an organic solvent, the organic component like oil, grease are removed. Then that article is passed through a dilute sulfuric acid, the solution or the chamber which contains dilute sulfuric acid, in order to remove rust or any other extraneous matter. Any other extraneous matter. Okay. Then, if you directly carry a galvanization process, then acidic medium, the rate of reaction, corrosion rate increases. So that's why you have to remove all dilute introduced acid. So that's why it is passed through a distilled water in order to remove the introduced acid content. Then even in the moisture, the rate of reaction is more, so that's why it should be dried. Then it is passed through a dryer in order to dry the component. Then after that, the article is dipped in a molten zinc, maintain a temperature of about 420 to 430 or 425 to 430 degree Celsius, which is covered by a ammonium chloride flux. See, this ammonium chloride flux is introduced in order to prevent the oxidation of zinc. In order to prevent oxidation of zinc. Otherwise, the zinc interact with the atmospheric air and get oxidized to zinc oxide. Instead of depositing zinc, zinc oxide may deposit, or deposition of zinc oxide may observe. To avoid that one, you have to cover the molten zinc with ammonium chloride flux. So that's why over the surface of this zinc, ammonium chloride flux is introduced. So that the deposition becomes only zinc, not zinc oxide. Okay. Then the dried article is passed through molten zinc covered with the ammonium chloride flux. And it is just a dipping process. We may observe if you dip any component to a thick solution, uneven deposition is observed. To make it to a thin and uniform coating, then that article or the sheet is passed through two hot rollers in order to wipes out excess quantity of zinc. So what the article we get after this process is considered or is called it as a galvanized iron sheet. Okay. This is the steps involved in the galvanization process. Okay. A iron sheet is passed first. It is washed with an organic solvent. Okay, it is well washed with an organic solvent in order to remove the all organic component present over the surface of the metal. Then it is well washed with the, or then it is immersed in a dilute sulfuric acid in order to remove rust or extraneous matter. Then it is passed through a distilled water to remove acid component. Then air dried, then it is passed through a molten zinc, maintain a temperature 420 to 430 degrees Celsius, covered by means of an ammonium chloride flux to reduce or to prevent, not reduce, to prevent the oxidation of zinc. Then the sheet is passed through two hot rollers in order to wipe out excess amount of zinc. And the process, what we called it as galvanization. That is, the first step is the iron sheet is subjected to pre-treatment. That process, what we called it as a pre-treatment by the degreasing with organic solvent. So we have to remove all grease or oil particle by dipping in an organic solvent. Then the sheet is passed through dilute sulfuric acid. You can maintain a temperature of 60 degree or not. If you maintain a 60 degree temperature, maintaining is a necessity when the thickness of that extraneous deposition is very high. Then to remove that one, you have to maintain a temperature of about 60 degree. Otherwise, just by dipping dilute sulfuric acid is also sufficient. Any rust or oxide layer, then it is washed with distilled water and then air dried. The iron sheet is dipped in a molten bath of zinc at 425 to 430 degrees Celsius, covered with ammonium chloride flux which prevents the oxidation of zinc metal. The excess of coated metal is removed by passing through a pair of hot rollers and cooled gradually. The main advantage is, since the coating is anodic in nature, the exposure of the base metal will not cause corrosion. The disadvantage is, since the zinc salts are poisonous to food materials. Okay, like in acidic condition, it get poisoned. Like if you use a citric acid like component, it get poisoned. So that's why it cannot be used for storing the food material. Cannot be stored in this container. What is the use of galvanization process in building reinforcement iron? In the manufacture of reinforcement iron, these galvanized articles are very important to make galvanized articles. In the making of roofing sheets, buckets, wires, pipes, etc. Even in the manufacturing of automobile parts, bolts, nuts, nails, etc. It's just by a dipping process. So that's why the process is very easy. So in each part, the entire part can it's possible to deposit a zinc component. Okay, so that's why we may usually use this zinc in the coating is used in the manufacture of galvanized iron particles. Iron materials. Okay, it is not used to store or prepare a food material because it gets poisoned if an acidic component interact with the zinc.